Alright, so in this video we're going to talk about indefinite integration 6.1, and I just want to start off with a quick review. So if I asked you to find let's say the derivative, so find, you know what, let me actually erase this and create some more space here. Okay, so I want you to find the derivative and then let's do a few examples here. So what is a derivative? So d dx of, say, x squared. Well, the derivative of x squared is just 2x. And if I ask you to find the derivative of, let's say, x squared plus 3, then the derivative of that is also 2x. And we can keep going here. So the derivative, so d dx of, say, let's do x squared plus, let's say, e, the number e, we would say that the derivative of that would be just 2x as well. So you might be noticing that the derivative of x squared, no matter what constant we're adding, is always going to be equal to 2x. So in general, what we can say is, and let me just scroll down here a little bit. So in general, I can just say that d dx of x squared plus any constant c will always equal 2x, because again, if you think about it, the derivative of x squared is 2x and the derivative of any constant is 0, so this is really 2x plus 0, but we don't really necessarily need to write the 0, so we can just write simply just 2x. And so the derivative here is equal to 2x. Now we ask the question, well, now we talk about this thing called antiderivatives. And really, the question that we ask when we're talking about antiderivatives, and let's just start off with this question: what is 2x the derivative of? And so essentially what I'm asking is, what is the antiderivative of 2x? In other words, what function, when I take the derivative of, gives me this 2x? So again, what function, when I take the derivative of, gives me this 2x? Well, if I take the derivative of this x squared, I get 2x. So I could just say, well, x squared would be one of them. So there's one of them. I could also take the derivative of x squared plus 3, right? I could also take the derivative of x squared plus 3 and I would get 2x. I could take the derivative of x squared plus e and I would also get 2x. And then finally, really, I can take the derivative of any x squared plus any constant and get 2x. So in general, so my general solution, this is what we call a general solution here, would just be x squared plus any constant c. And so what I'm essentially saying is that if I take the derivative of any function that looks like this, I will get 2x as my derivative. Now, and we call this guy here, I should label this here really quick, we call this guy the antiderivative. So this is the antiderivative of 2x, because when I take the derivative again of this guy, I get this 2x. And we introduced some weird notation in this. Ooh, I dropped off the N here. Integration. Sorry about that. We introduced some interesting notation in this section here, and you know, you can kind of think about this as a squiggly elongated S, but it looks like this. So the notation that we use here notation looks something like this, where I have this long squiggly s here attached with a dx. I will talk more about what this notation represents, in the next section. You'll know more about this here. But for this section, for this particular section, the only thing you need to understand is that this notation here tells you to find the antiderivative. And whatever function is inserted in here, so in our case it is 2x, so that was a function that we were talking about. So here, this is our function, and I'm going to write, this is our derivative function. And really what this notation is telling us to do, so all this thing is telling us to do is find, let me scroll down a little bit. This is just telling us to find the function, oops, let's see here, give me 1 second. What's going on? Okay, so sorry about that. My computer was acting up there. I think it froze for a second. But anyway, what this here is saying is find the function whose derivative is 2x. And so if you think about that, we've already essentially done that. You found the antiderivative. In other words, this thing is equal to, so let me, this thing is going to be equal to x squared plus c. This is the function that when we take the derivative, we get this 2x. So this is a function whose derivative is 2x. Now, in the next upcoming videos, you'll see how we actually apply this to a more you know, specific definition than just some type of weird, funky-looking symbol here. But essentially, for right now, that's all this means, is just find the function whose derivative is this function inside, in this case, 2x.